In this presentation, we'll take a look at databases and the organization of data, one of the more fundamental concepts in information sciences and technology. Let's begin. When we talk about databases and the organization of data, some terms that often pop up are data, information, knowledge, and wisdom. And often we want to take a look at what is the difference between these terms. Now, to put this kind of in perspective, if we look back at an old poem by a poet called T.S. Eliot entitled The Rock, there's a few lines in there that are particularly salient for what we're going to talk about today. Where is the wisdom we have lost in knowledge, and where is the knowledge we have lost in information? Well, let's take a look at how these terms relate to one another. A psychologist named Russell Ackoff put together a data hierarchy of terms and helps us to understand the difference between them. At the lowest level is data. These are simply raw facts or numbers that have no real meaning. In general, you can think of something like 21.2 as just a piece of data. By information, we mean raw data that's given meaning in some context. Using the earlier example of 21.2, we could use that to form information by saying something like, this car gets 21.2 miles to the gallon. In that sense, we have taken a piece of raw data, 21.2, and used it to make information. Knowledge is the simple storage of information, like in your mind or on a computer hard drive. It does not imply any analytic or cognitive capability. It's just simple storage. Understanding is the ability to synthesize new knowledge from old knowledge. This does imply cognitive or analytic capability. Wisdom is the ability to apply knowledge and understanding with morals, ethics, and other factors to make decisions and to apply understanding to situations. This is the highest level of this hierarchy. So what is a database? A database is nothing more than a computerized record-keeping system. In general, databases are collections of computer files organized in some logical way. So why do we use databases? Well, databases are a means of storing data for further analysis, further distribution, and archiving, a way to keep data around for years to come if that's mandated by such as legal statutes or just for being able to access that data over time if necessary. Now, when we use databases, we often make queries on those databases. Keep in mind that a query is a means of asking a question about a set of data. It includes things like retrieving data, but it can also include things like updating data. For example, if we wanted to know what our sales were 10 years ago, we could use a database to figure that out. Databases also have meaning and use in an organization. They're often a vital piece of the organization and its strategy. And databases are persistent, meaning the data is maintained over time, and changes to that data are managed by a special piece of software called the database management system. So what are our database software options? Well, there are many vendors out there, but here are the key ones. IBM is one of the leading vendors of database software. They have a product called DB2, among others. Oracle is the leading vendor of database software, being the second largest software maker in the world. An open source option is MariaDB, and another is MySQL. Whereas Microsoft also has a product in this marketplace called SQL Server, and one that we're going to explore a little bit this week called Microsoft Access. There are four components to any database system: data, hardware, software, and users. By data, or when we talk about data, we're talking about data that is integrated, often from various sources and in various forms or formats. Data is shared amongst the people and systems of the enterprise. And with data, we attempt to at least partially eliminate redundancy or the duplication of data. By hardware, what we're really talking about are the primary and secondary storage and processors. In other words, the RAM, the hard drives, things like that. This often involves multiple machines, drives, and locations. When we talk about software, the software we focus on is the DBMS, or the Database Management System. This is software that acts as an intermediary between storage and the end user, a guardian, if you will, of the actual data. It provides an abstraction of the data so that users can be presented with a pretty visual picture of the data and not have to worry about the bits and bytes that are actually stored on disk. By users, we're talking about the people and the systems which use the database and the data therein. Often these groups each have different interfaces, whether it be a web page, whether it be a simple form, whether it be a terminal interface, kind of like you had with PuTTY last week. Now, database features, of which there are many, are summarized here. These are just a few. Databases provide fast, efficient access to data, but they also provide centralized control of data, unifying different pieces and different sets of data from across the enterprise under one umbrella. By doing this, we can make queries of our data and learn more about our organization, about the world around us, or what have you. And we interact with the database through things like forms and reports. Data integrity, which is in the lower right, is also a very important feature of a database. We bring data together, we want that data to be valid so that we can make good decisions based on the data we have. By data integrity, what we're saying is that the DBMS, whatever that may be, is intended to keep the data valid and secure. Now, ultimately, data is the most important or precious business asset. Because the database serves to unify the different data within the organization, it standardizes the meaning of data across an organization. So everyone is on the same page, and the organization can better act to achieve the strategic goals that it's set for itself. However, like tribbles, data can multiply quickly, and that growth can be very, very hard to control. We are inundated with more data than ever before, not just us as individuals, but organizations in both business, nonprofit, and governmental. How we manage that data and how we leverage that data to achieve goals is a fundamental problem in IST. Today, what I'd like you to do is start taking a look at this activity, which is on Canvas in your Lesson 5 module. It's called Introduction to Databases, and it has the letters HOA in parentheses after it. This is an introduction to using Microsoft Access, which is installed on the lab computers on campus. So what I want you to do over the next few days before Wednesday's class is start on this. Some of you may indeed finish this. You'll have time in class on Wednesday to work on it as well, but it's a really good idea to get a good head start on it because it does involve a lot of steps, but it is very much step by step by step. So do take the time to read every direction carefully and work in the order in which the steps are listed. I will see you Wednesday. Have a great week.